Hello students. So in the previous video you have seen about the dot product and vector product of two vectors, and at the end of the previous video I have given you the equation for work done. So let us continue with that and just see what is work, how it can be defined and what are its units. Now here, as you have seen in the previous video, that work done here can be written as dot product of force vector and displacement vector. So we can define work as, work is defined as the dot product of the force vector and the displacement vector. You know that you can write here dot or scalar product. So W is F bar dot S bar, where F bar is a force acting on a body, S bar is a displacement produced in a body, and W is the work done by this force. We know by the definition of dot product, W is equal to F bar dot S bar or vector F dot vector S, and it is equal to Fs cos theta, where F is the magnitude of force vector, S is a magnitude of displacement vector, and theta is the smaller angle between force and displacement. When I say theta is the angle between force vector and displacement vector, it means it is clear that we are choosing smaller angle. Theta is a smaller angle between force and displacement. Okay. Now, see, when you study in higher classes, you will see that if I can rewrite this in this way, W is equal to, I can write this as F cos theta into S, or I can also write it as F into S cos theta. All these three are same. Only the way of writing is different. Now, when we add two or more vectors, the answer that we get is called as resultant of the given vectors. Okay, suppose we are adding two vectors and we get the third vector. So, third vector is a resultant of first two vectors. Similarly, a given vector can be divided, can be resolved into more components, okay, in different directions. So, in higher classes when you see that if F force vector is split into different vectors, then F cos theta is a component. It is a component or split part of force which is in the direction of displacement. Similarly, F into S cos theta, here you will see that S cos theta is a component of displacement vector in the direction of force vector. See, component means what? When you split a given vector into different parts which are along different directions. So these parts are called as components of the given vector. So if F cos theta is a component of force vector in the direction of displacement, or S cos theta is a component of displacement vector in the direction of force vector, so we can also define this work as the product of magnitude of displacement and magnitude of component of force vector in the direction of displacement vector. Or we can also define it as product of magnitude of force and magnitude of displacement in the direction of force applied. Okay, so you should know this. So W can be defined in different ways. Now, in 9th class, you will not find this dot product concept. You will not find cos theta anywhere. You will directly have this equation for work done. W is equal to F into S. Now, we cannot say that this equation is wrong, but at the same time, these equations are also right, and all of them should be similar. So if here third term is missing, third term means third part of this product, it is actually one term only. So F into S into cos theta, this cos theta is missing here. So where it has gone? You know, in the previous video we have seen that cos, you have by-hearted the three values of cos. Cos 0 is 1, cos 90 degree is 0, and cos 180 degree is minus 1. You know, theta is the angle between the two vectors, force and displacement. So for theta is equal to 0 degree. When theta is 0 degree? When force and displacement are in the same direction. for theta is equal to 0 degree, cos theta, which is cos 0, is equal to 1. You know this. So in this case, if this cos is missing, it means it is 1, because f into s into 1 will be equal to f into s. So we can say here that this equation is actually there when force and displacement act along the same direction, or they are along the same direction. Okay, so in your 9th class, there is no need to, you should know this concept, because then only you will understand the chapter properly. But in 9th class, you will see this equation, and so you can define the work according to this equation. So how will you define work now? Work done is defined as the product of magnitude of force applied and magnitude of displacement produced in the direction of force applied. If you just write it as work done is defined as a product of magnitude of force applied and magnitude of displacement produced, your definition will be wrong. You will lose your marks. You are supposed to write work done is defined as a product of magnitude of force applied and magnitude of displacement produced in the direction of force applied. Okay, so this is the definition given in your NCERT textbook, although you can also write it as magnitude of displacement. Work done is defined as a product of magnitude of displacement produced and magnitude of force in the direction of displacement produced. So hope now you know that if you don't write in the direction of force applied, in the direction of displacement produced as per your definition, you will lose your marks. So NCERT definition you have to by heart. I will repeat it. So for you, when the question in the exam comes, define force, you will write, define work, you will write work done is defined as a product of magnitude of force applied and magnitude of displacement produced in the direction of force applied. Okay, so now you know the definition of work which you are supposed to learn and write in your exam. Now if I ask you, is work a scalar or a vector? You know that as it is a dot product or scalar product of these two vectors, so it is a scalar quantity. So work is a scalar quantity represented by capital W. Now let us talk about its units. Remember students, in NCERT we are considering only absolute units, although just like force and weight, there exist gravitational units for work also, but we'll be dealing with only absolute units. Okay, so I will not mention it absolute, I will just call it SI unit and CHS unit of work. You should remember, we are always considering absolute units. So SI unit of work, from this equation when you see, just see the right hand side. You know force SI unit is Newton. Displacement SI unit is meter. So SI unit of work should be Newton meter. Yes, it is right. Newton meter is SI unit of work, but it is given a special name in the honor of scientist Joule. This is Joule. Okay, so SI unit of work, now you will say is Joule, Joule. When you write the complete spelling of the unit, you will start with small letter J. When you write its symbol, it is capital J. So, you know, as we have defined Newton from F is equal to ma, similarly, you can define 1 Joule or the SI unit of work from this equation. Now, W is equal to F into S. You know that work done will be 1 Joule. This will be 1 Joule when force is 1 Newton and displacement is 1 meter. Okay. So, how will you define Joule now? 1 Joule. Work done is said to be 1 Joule when 1 Newton of force acting on a body displaces it by 1 meter in the direction of force applied. Again here, if you don't write in the direction of force applied, you will lose your marks. The definition will go wrong. So, state the SI unit of work, Joule. You can write this. Define it. You can write these steps and you can define it as work done is said to be 1 Joule when 1 Newton of force acting on a body displaces it by 1 meter in the direction of force applied. And And remember, 1 joule is 1 Newton meter. Okay. Now, similarly, let us see the CGS unit of work. CGS unit of work. What is the CGS unit of force? Dyne. Displacement, centimeter. So CGS unit of work is dyne centimeter. This should be your first answer when you are asked to give the units after writing this equation. And it's right. It is again given a special name, Erg, E-R-G. Okay, so when you are asked to state the CGS unit of work, you should remember ERG. Erg is the CGS unit of work, and erg is 1 erg is equal to 1 dyne centimeter. How will you define this unit? How will you define 1 erg? Work done is said to be 1 erg when, work done is said to be 1 erg when 1 dyne of force acting on a body displaces it by 1 centimeter in the direction of force applied. Okay, so I hope it is very easy for you now to define the units from the given equation. So you can define joule, you can define erg, and let us see now conversion between joule and erg as we had seen it earlier between Newton and dyne. So let us see conversion between joule and erg now. We know that W is F into S, and by definition of 1 joule, this is 1 joule is equal to 1 Newton into 1 meter. We know that, let us do the conversion here. 1 Newton we know it is equal to 10 raised to 5 dynes into 1 meter. Let us convert this into CGS unit centimeter. It is 100 or 10 raised to 2 centimeters. So multiplying this to 10 raised to 5 plus 2 is 10 raised to 7 dyne centimeter. But now, just now we have seen that dyne centimeter can be written as erg. So 1 joule is equal to 10 raised to 7 erg. I hope now you have learnt the definition of work. You know it is a scalar quantity. You can state and define its SI and CGS units, and also you can do the conversion between the SI and CGS units of work. So we'll continue with this chapter in our next video. Hope you have enjoyed it, understood it. Thank you, students.